And we're live, I hope. How's everyone doing today? Hey John, how's it going? Oh, the AC. 1 second. Be gone, AC. Okay. So yeah, this is day 18 of studying compilers every day until I land a compiler role. Yeah, I guess same deal as yesterday. I will be doing the daily and then just continuing on with the kaleidoscope tutorial. Hopefully I can make some good headway into, or I guess just like finish this chapter, honestly. That would be quite nice. Let's see. Alice and Bob, our beloved. Okay. There are X flowers in the first lane, Y flowers in the second lane. So we're given... Okay, I see. So Alice takes the first turn. Each turn, a player must choose either lane and pick one flower. If there are no flowers left at all... Wait, what? Okay. If there are no flowers left at all, the current player captures their opponent and wins the game. What? Ben, have you used Kubernetes? I have not. I really should at least get some experience with it, but also like I haven't had a reason to, so I haven't yet. What is this? Wait, this is... I feel like this problem shouldn't be that difficult. This is just like math. Alice must win. Okay, so it's just an even sum then, right? Or odd sum, rather. And then each has to have at least one. Yes. Oh, it's a long. That doesn't make me feel comfortable. You mentioned Aiden's stream last night, and I was like, damn, I should learn some Kubernetes. Yeah, I kind of feel that too. Minikube, I see. Oh, I see. Okay, that makes sense. Yeah, Kubernetes is in like a really weird place where I think it never really makes sense to use for like a personal project unless it like massively blows up. And unfortunately that doesn't really fit any of the projects that I really intend on using. Yeah, it is absolutely just unnecessary for most people. Like most things that people make, I don't think would get the amount of traffic to even justify it. I could see it. Yeah, I feel like even medium to large apps, that is a little bit of a stretch. I feel like it mostly belongs with just like the large production apps that companies have. And like large companies that need to like truly service a lot of people. Okay, so we can do a little bit of math here. Let's see, how do you want to do this? Okay. Number of pairs, okay. So we have to do a little bit less counting then. So let's get the... What do we want to iterate across? We want to iterate across... Let's do n for now. Yeah, these are ints. But at the same time, you can do a simple implementation of Kubernetes. Yeah, I feel like, at least for personal projects, the value of it would just exclusively be pedagogical. I don't think it would really, I don't think it would really bring like value otherwise. Okay, so we want to differentiate the even and odd. Wait, no, we don't need to simulate this. This is overkill. Return, we could probably just one-line this even, because we only need to count. So it's, this is like this problem seems like just a big rounding mess. So n divided by 2. Actually, we want to see if they're even and odd, because that will affect the math. What is the best way to do this, anyway? I guess I'll just like enumerate all the logic first. So let's do greater. Let's do odd n equals n so that would mean that it's odd. So then that would be n divided by 2 plus 1. Else, actually, you should probably just divide by 2 anyway. I just want the no down rolling updates. Oh yeah, that makes sense. That's pretty fair. I guess there isn't really any other good solution to that other than just Kubernetes that I know of, at least. I could also just be completely out of my knowledge on that though. So who knows, I guess. So odd n equals oh, we can just n minus even n. Actually, okay, wait, I have an idea. So we have n minus, let's just do half, let's call these half. Times half m plus m minus half m times half n. This should give the correct answer. Uh-oh. Oh, that's a problem. I forgot. Let's make these long. Oh, you're so right. Wait. I mean, I guess it doesn't matter at the end of the day, because it's all constants, but... Good comms. Actually, no, it gets optimized away anyway, so it doesn't matter. You can do it with Ansible or just bash scripting, but Kubernetes does make it very easy. Yeah, that makes sense. Yeah, I did completely forget about BitShift, which was really funny because I was using bitwise and. So it's like, surely I think of that. Yeah, I mean it gets optimized away anyway, just at the people level. So yeah. Actually, does that mean that I can get away with just throwing this in here? Let's give this a try. Okay, I guess I can't. Yeah, we'll just leave it as is, call it a day. Yeah, Bitwise is great. It just always feels so clean to use. Anyway. Let's see if anyone's complaining in the discussion. Hint? Yeah. These are pretty funny, actually. It's high time for Alice and Bob to find a job and stuff. What are we saying here? Was this hard to understand? Am I missing something? This doesn't seem difficult to understand. Like you just keep picking flowers until there's no flowers left. I don't know. Anyway. Hey Janine, how's it going? I speedrun the LeetCode daily. So that's done. Now we get to do real things. So we go back to kaleidoscope. That's, yeah. Where'd all my TMUX sessions go? Oh yeah. Okay, first try. Let's see. Where did we get to last time? We got through changing the existing variables to use stack variables instead. So it's in some of the code gen, but yeah, as an example, here in variable x_ast, we just use allocate instructions to, I guess, represent the variable initializations, and then we just use allocates instead. And the idea is that mem2reg will just turn whatever it can into variables. And that gets around the whole SSA construction issue. So now we need to, so we've changed the variables inside for loops and function params. So now we just need to, I guess, take those variables and then generalize them to be like human usable. Yeah, let me put this here. Yeah. Assignment operator. So we need to do that now. So let's see. Yeah, we just add another operator. That's, yeah. And it's right here, nice. I forgot I moved it here for a second. So this is the precedence order, so then it would go down here. And this is just assignment, so yeah, I guess that precedence makes sense. What did I do? Okay, there we go. First try. So it knows it exists, and then we just need to implement CodeGen. And this is a special case. Yeah, that makes sense because it doesn't like operate on. It's not really like a. I guess consuming isn't the like technically correct word here, but you kind of get what I mean in that sense. Like it takes two values, but it doesn't. I guess like it isn't like a mathematical operation on those values. So let's take up. Then let's do that. It feels strange not seeing ligatures in the LLVM docs because I have them. I forgot to turn them off on Firefox on my Linux machine. So now we're just on like Windows defaults, and I guess Windows does not use JetBrains Mono. Okay, so we create the variable expr. Static cast. Oh, I see, okay. That makes sense. So we want to see if it is a variable expr because we want to avoid assigning a number to a number or a number to a number with that level of emphasis. And then left-hand side is a left. And left is a unique pointer, so we need to call get on it. So if this is a null pointer, then we will error it. Yeah, let's do that. Must be variable. I should get undercurl working on this. This visually does not please me. Unlike the red? Okay, I read that already. Okay, so now we just CodeGen it. We CodeGen it and we like literally create the variable. So we CodeGen the right hand side. If that doesn't exist, then we also null pointer. Whoops. Look up the name. Oh, yeah. Do we ever CodeGen the left side? Am I just being dense? Eh? Is initialization separate? Is that what I'm missing? Eh? Okay. I mean, sure, I guess. So let's take this value and then so we've cogened it. Now we need to get the name. So we get named values at left expr. Do I not have a get name for... Wait, no, it's an LVM value, right? No, it's not. Oh wait, we've already initialized it, right? Is that what's happening? Wait. I'm quite confused. Oh, now we do that after. Yeah, var. Okay, that makes sense then. That explains a lot. But then we're missing a get name on that. So this is a variable x for AST. Yeah, we are missing a get name. So let's throw in is a const? No. Yeah, no. This wouldn't have any const on it. So let's just throw this in real quick. Oh. I put the semicolon in the wrong place. I forgot to put... There we go. Anything major I'm missing here, logic-wise? Maybe this should return a const? Language seems to like that. This seems sane enough. Ben, what programming languages do you like? I'm quite enjoying C++ actually. It generally seems to make sense to me, and it has the complexity that I find enjoyable in computer science. I haven't worked with Rust enough, but the little bit of work that I have done, I've enjoyed it. So I imagine I'll like that a lot. Yeah. I think as long as the language just doesn't have nonsensical design choices, and as long as it doesn't rhyme with JavaScript, I think I'll be fine with it. I guess that's kind of a non-answer, but I mean, yeah. I guess Python has its gross moments as well sometimes, but I can kind of get around it because you can kind of justify it. I think like for JavaScript, the big one is just like the way typecasting ends up happening with a lot of things. And I think like when I like first read about hoisting, it really left a bad taste in my mouth. Cause it's like we definitely knew that was gonna be a bad idea. Because like we knew Java existed, which is the whole reason we like tried to tack onto the name. And like we still managed to mess up that badly. Like I guess it kind of makes sense given like it was written in what, like 2 weeks? But even still, it's like we could probably have like a little bit more reservation over that. Another one is like, I think Python continuations are a little bit awkward. Or what was it called? Python, it's in the decorator implementation. Yeah, dynamic types are in generally just kind of a mess. What's the thing called? Pass, not pass, that's default. It's like the thing that like hands it back. I forgot what it was called. If anyone in chat knows, feel free to save me a little bit of scrolling. Where did it go? What's it called? I'm like really getting sidetracked, but this is very worth it. I must figure it out. What's it called? I definitely used it before when I made a decorator. It was like a wrapping thing for it. Okay, let me open up the file real quick. I don't know if this is like code that I can like literally share, so I'll just do it on my other monitor real quick. What do you think about giving a function the ability to return early from the function that calls it? I mean, I feel like this has already been pretty litigated out, just in general with like the whole goto mess. Oh, my SSH is not set up properly on this. 1 second. Okay, other machine. We're really struggling here. Yeah, I think this issue really is just. It's like we've already like had this conversation with goto. There's a reason nobody wants to use it. Where did it go? Oh, come on, I got rid of the code that implemented the thing. Well, anyways, it's in a function where you like pass in a function call, I think. It was something like that, but there is a keyword that lets you like return execution back to the outer function. It was like really gross. There was some paper that was like explaining the bad design choices in Python, and it mentioned that. and it leads to some like really strange logic with global variables, and it causes like a whole scope mess. So yeah, that's an example of like what I don't like about Python. I also think just like everything being, or I guess like things not really respecting scope is also a pretty big problem to me in general. It just seems like it causes a lot of unintentional logic issues. And like I didn't really think about it a lot when I like first started programming, because I was like I was kind of like, oh yeah, like if you know what's going on with globals and like you can do more powerful things with your code. Yeah, high school me was really dumb. That was not a good take. That was not a good take in any semblance, and I very much regret having that take. And return val. Python kind of sucks, but it's nice to have their standard library for LeetCode. Yeah, that's fair. I also think it's just like really easy to debug as well. Like, barring the language design issues, at least for like simple code at like the LeetCode level, it's pretty easy to like figure out what's going wrong. And it just, like from a moving fast perspective, I kind of get why it's so popular. But like JavaScript is like, we could have picked literally anything else, and we chose that one. Like that one kind of sucks. Python Vim and package runtime /runtime management's a nightmare. Honestly, I kind of disagree with that. I feel like that's one of the things Python does do well, because like, at least from a C++ perspective, like C++ literally has no package management whatsoever. And it's just like kind of a mess to worry about. And like, I think Python and Rust's native package managers are the only two that I like. Oh yeah, this exists, sure. Adding the var/in is just like any other extension. Extend the lexer, parser is, does in already exist? Yeah, it does. Okay, sure. So let's go to lexer. That's a comma. Let's see, get toke. This tree will just forever grow, I guess. Var return toke. Var. Sure. Find the AST node, sure. Let's go back here. Wait. This is distinct from variable expr. Let's drop down here. Let's see. Is it distinct? Did we call it something different? Yes, it is something distinct. That's this could not possibly get confusing at any point in the future whatsoever. And so then extends public expr ast takes stood vector of vector of pairs of. string to expert AST pointer. Huh? Okay. Sure. It's public and private. Yeah, let's do the fields first. Vector of pair of string to unique pointer of type expert AST. Oh, that's enough brackets. Okay. Wait, no, it's not. There it is. This field is var names. Okay. It allows a list of names to be defined. I see. That's why. That makes sense. I really want to alias the pair thing. I might do that actually. Let's steal code gen. And then let's make the constructor. This constructor is going to be really ugly if I don't do the thing, so I'm going to do the thing. Let's put it here. Steal that. Using and then what am I calling this? I'm calling this var name pair. What am I messing up? Okay, we need to put this down here apparently. Or even further down. Name defined must be an identifier. Oh, other way around. You tell me that you're gonna study compiler each bloody hell you day until you get a job. That's the spirit. Damn right it is. That is, in fact, the plan. Okay, let's go down here. Let's change in this vector of our name pair. Much prettier. I don't know if this is like good C++, but it's a feature, so I'm gonna use it. It's a feature that isn't GoTo, so I'm gonna use it. var expert AST. So the constructor, this takes the vector of var name pair. And then this takes body. Pointer of expert AST. Okay. So we have this. Now we can steal. Let's steal this one for now. We'll steal the other one later. And then this goes after for loops. Yeah, here we are. So there's that. We need to initialize this. Var names gets var names, and then body gets move. There we go. Okay, we still have to format it, but this is a little bit less gross than it was before. And then we need to worry about code gen, I think, right? No, we need to parse first, and then we can worry about that. Yeah, so we can now make the thing, so now we can parse the thing. Yeah, we're gonna need parse var expr. We should define this in here. Let's put it here. Is that all we need in here? Yeah, that's all we need in here. That's pretty nice. So steal that. Parse function. Or no. Parse for this needs a parser on it. And then, yeah, let's leave this here for now. Let's add this to parse primary first. And then case tokvar. Okay, and then we go back up here. And what do we put in here? All right, so we eat the var. We take the, we have to handle all the pairs here, it looks like. Is there an example of how this is called? Somewhere up here? Oh, guess not, okay. And then, oh, okay, this is a little bit ugly. Okay. So you eat the var, we make the vector what did I call the pair class again? Var name pair. There we go. Yeah, that's way better than this yucky thing. So if we don't have an identifier next, because we need at least one variable name in this, we error out here. All right, real quick, I'm gonna run to the bathroom. If you're still here on the stream, make sure to like and sub real quick. Yeah, I'll be right back. Okay, I'm back. Glad to see the stream hasn't burned down my house yet. Good to see everyone's still here. Yeah. Parse var expert. So we've eaten up the initial var token so far, and then we've checked that we at least have an identifier. So now, is there a try catch in this? No, there is not. Okay. We while true this. Sure. So now we get the identifier. And then if there's an initializer, then we eat that and we read that. Regardless, we add the variable and then we check if there's more variables. If not, then we just exit the loop. And then we do this again. What if I just made this a do while or something? I don't know. I'll do it the way that they say at least for now, and then we'll go from there. So we get the identifier, we eat the token, we get the initializer, if the current token isn't equals, then we have an initializer. So we eat up the equals, and then we want to parse what this is. And if that doesn't exist, then we return null pointer back up the recursion. So then we take var names, can I in place back here? Is this a thing? Okay, it looks like it is a thing. That makes sense. Interesting. Yeah, okay. So that makes sense. This seems like the C++-y way to do this. Unless there's like something insane that I'm missing. I could probably make a do while loop here, even. Yeah, I'm gonna make this a do while. So then, while cur toke is not, comma, And then we can steal this. We can put this up here. We can take these. We can put this here. And let's format that. Yeah, this seems about right. Is there something I'm missing though? Yeah, because this either eats up the comma or the var. Adding that for myself because I sure as hell am going to forget that. Logic-wise, this should be fine. If it's not fine, then like unlucky, I guess, but... So we've parsed all the variables up to this point. Parse the body. Is there like an example usage? I think there was somewhere up here, right? I swear there was an example. Maybe it's just at the top? Ah. Ah, in. Yeah, okay. That makes sense. We just literally have like scoped variables, I guess. Okay, so now we read current token. So if it's not an in, then we, after var, and then we eat that token. So now we parse the body. Parse the expression. If that's a null pointer, then we return null pointer, and then we make unique. Oh, okay, that fits in the line. Interesting. What happens if I insert a line break? Okay, it rejoins it. Interesting. So now we just need to do code gen. And I think we're actually done with this chapter. I guess we did most of the bulk of it last time, so fair enough, but yeah. Seem to be moving pretty quickly. So now code gen goes here. Okay. Oh, okay. This also handles like scoping the variables. Okay, so we just displace the old bindings and then we code gen the body, and then we restore the old bindings. That seems simple enough. A little bit of indirection never hurt nobody. A little bit of indirection definitely hurt somebody, but hasn't hurt me yet. Oh, I didn't start at the top. Whoops. So we make the old bindings vector. We get the function. And then, okay, we initialize them. So allocate instruction pointers. So we make the old bindings. We get the function. And we register the variables. Yeah, okay. What's the best way to do this? I guess the way they show, to be honest. Oh, these are all one thing. Why does it do it this way? I assume it's to avoid like calling this at each iteration, but why would that matter here? Is it just like a good practice thing, or? Let's ask chat. Yeah. Okay, this one makes sense. I see. Actually, that makes a lot of sense. I should probably do it like this. Just like more in general. Yeah, that makes a lot of sense. Okay. I guess that is a little lesson for everyone as well, for anyone that's writing C++ code. And also I use postfix because it looks nicer. At least I think it looks nicer. So we get the var name. So that's the first value, and then the expr is the second value. Yeah, okay. So we have the second, oh, it's a unique pointer, right. Okay, so, oh, whoops. There we go. Okay, so I guess this section of the code is not done yet. So let's keep chugging along, and then I'll try and re-explain everything again. So we want to code gen the initializer first. Yeah, so then we don't have like annoying sequencing things with shadowing. I guess like it solves the sequencing issue. So if init exists, then we code gen it. Sorry about that. If the code gen fails, then we return null pointer back up. And if it doesn't have a value, we default it to 0. I guess that makes sense. I'm sure this won't cause any semblance of logic issue, potentially. Wonder if I can do some like dumb ternary operator stuff here. Yeah, let's give this a try. So constant fp get, this takes in context pointer and then ap float 0. Ah, that's what it's mad at. It seems, yeah, that looks good to me. And then we still need the null pointer check, it looks like. So let's just steal that and call it a day. Hey Harsha, how's it going? Okay, so we've done this part. We need to create the allocate. And this is, so this is like literally initializing the variable. And then we need to store the old bindings. We need to store the old binding in old bindings, and then we need to set this current new binding to the new binding, I guess. We have this nice little helper we wrote last time. And this is function, and then this takes in var name. Or sorry, just name. There we go. So we've made the thing, and then we need to create the store. And this takes in the init val, which we had, and then the allocate itself. So then we have old bindings dot push back. Takes in values at var name. Where is var name coming from again? Oh, it's name. Of course it's name. And then what's the other thing we need to do? We need to update it. So name values name is now the allocate. The address of the allocate, rather. Address of pointer to? Pointer to. Okay. Yeah, this all seems roughly simple enough at least. So now we actually have to code gen the body. So this big for loop that we just wrote, it pretty much it takes all the variables that we've declared and maybe initialized. If it's not initialized, it gives it the default value, and then it makes those existent. So now we need to code gen the body that uses those variables, and then after that we basically nuke the variables and restore the old variables. Yeah. I think that logic is simple enough at least. So we have value pointer. Yeah. If it doesn't exist, let me just return null pointer. And then we restore previous state. And then we can just steal this loop header. Okay. First, so at the name, we set it to old bindings I. That makes sense. And then we return the body. Body val. Okay. So now we should have user-defined variables completely implemented in theory. So let's write a quick test for this. Actually, let's build this first. Let's see if this even builds. It should build, but We'll see what happens. Ah, I see. Where does this come from? This comes from... that doesn't help me. In AST, it looks like. It's in the constructor? Where is this being called? Oh, this might be the in place. Is it? Yeah, this is fun to read. This is breaking in AST, that's for sure. What's happening? This seemed fine. Is there like a unique pointer thing I'm messing up? The copy constructor. Where is this happening? Oh. Yeah. Why is this erroring? Is it that? Oh, it is that. No, it's not that. What? Wait, what? Okay, I got pranked. This is fun to trace. Where does this come from? Implicitly deleted copy constructor of stood pair. Where is this? Ah, here it is. Varnames, varnames. This goes up here. I feel like it's gonna be something really stupid. Yeah. Yeah, okay. That makes a lot of sense. Because the vector has the vector of pairs of string and unique pointer. We can't copy the unique pointers. So we would need to just move the whole thing. That's good practice anyway, I guess. Should be somewhere here, right? Yeah. Okay, this should work then, surely. Yeah, it's looking promising. While we're waiting for this to build, if you have not yet, make sure you sub to the channel and like the stream. It really helps me out with the algorithm. And it helps get my content out to more people. If you don't like the content, then like fair enough. Maybe if you want to, by all means go dislike. But yeah. So this builds, so we can let's run this. This is the test program here. So let's use the continuation operator real quick. It's one precedence, x, y. So this gets a var a equals 1, b equals 1, c uninitialized, or I guess default initialized, in. So we have the body here, and then we return b. Oh, we can't use arrows here. Okay, we have to one-shot this. This is a little bit ugly, but it'll work. Uh-oh. What did I mess up? Why that seg fault? You should be in scope. What's going wrong? Actually, let me just throw this into a test real quick. Yeah, let's do all this. Actually, let's take this one. Where's our, there it is, print line. So this goes up top here. Okay. So it is in fact struggling to read something. Where do we think it's going wrong? I think it's going wrong in the parser, actually. Because we can actually just look at this error message. Aha. In place. Whoops. Oh. Okay, well it's still not working. Oh, I think that's why. Let's make. I think I had the condition wrong. Yeah, because the break condition is opposite. So this should, yeah, there we go. That looks good to me, roughly. Let's see. I want to be in tests. That's where I want to be. First try. Yeah, let's throw in a print in here. Do we need to throw in a print? Nah. Let's just call this a couple more times and throw away all of the runtime gains we got from making this iterative. You know what? No, we make a for loop here. For int I, not int, ints don't exist. I equals 5. I less than 11. We'll do, or in print line fib I of I. Okay. Yeah, looks good to me. Okay. Cool. So let's add this stuff real quick. Oh, what am I doing? Rec? This is not recursive. It's actually the wrong name. Iter. Let's see. What are we calling these? We're calling these add. It's at the top here. Add mutable user definition for mutable variables. Yeah. Let's push this. One other thing I want to test real quick is if the other parse, if the like file input proper. Oh yeah, the file doesn't exist anymore. Okay. So then Let's disassemble, and then let's take a look. I forgot to turn opt back on. So it's in here. So let's rebuild this. And then we should be good to go, I think. Yeah, it looks good to me. So let's do that. Let's disassemble, and then, yeah, okay. It looks good to me. Okay, so this is just a continuation thing. This fib we don't care about. I think this one we care about. So yeah, it looks like it's handling this correctly. Yeah, okay, nice. All right. Let's see, do I want to start chapter 8 yet? I feel like I should start chapter 8. That seems like the responsible thing to do. I guess I'll take a peek at it, and we'll see how long this is. Where does the code listing start? Oh, this seems pretty short actually. I don't think we need to add that much to this, so. It is native support for cross-compilation. You can compile to the architecture of the current machine, or just as easily for other architectures. Here we will take the current machine. So I guess like a little bit of context for everyone viewing, in case you're not very familiar with general compiler theory. How do I break this down? So what we've made so far is we've made a language front end. So LLVM's infrastructure is based around their own language that all of their optimization support is built for. So the idea behind that is instead of given like M languages and n possible assembly sets, and having to write n times n compilers, because you would want one compiler per combination of source language and assembly, because different computers have different assembly languages. Instead of having to write m times n compilers, we can write m front ends that translate the source language to the IR language, and then n backends that go from the intermediate representation language down to the assembly. And currently we've written a front end, but just so we can get more experience just like using LLVM and their provided tools, we're going to call the existing backend for whatever system we're on. So to add that, we need to write very little code, actually, it looks like. The big thing is just like understanding what the existing infrastructure provides. Yeah, so we can compile to our current machine or compile to other machine code. So we need a target triple. This takes the form of that, and then that stuff. I should take a closer look at this. Why is it called a triple? This doesn't seem like a triple at all. Wow, LLVM is so useful, yeah. quite neat. We love it. Oh, it's this guy. We like this guy. Yeah. Yeah, okay. That explains a lot. Sure. Interesting. Okay, I guess this kind of roughly makes sense. So, yeah. I think I'll probably read this offline, but for now I'm gonna try and just chug through this part of the tutorial. So let's see what Kling thinks we're using. Let me... Just had a crazy day of meetings and reading docs? Yeah, unlucky. And you get to tune on to stream where you get to watch me read docs. Alright, Kling. Does Kling exist? Yes, it does. What's the output without the grip? Okay, that makes sense. Okay, so we're on Red Hat. That makes sense because this is Fedora WSL. Okay. Okay, so there is a way to just get it. That's nice. Doesn't require us to link in all the target functionality. If we're just using the JIT, we don't need the assembly printers. That makes sense. If we're only targeting certain architectures, we can only link in the functionality for those architectures. So this is the big POW for object code. Okay. So given this target triple that we got here, we can use that to get a target. Nice. We also need a target machine. LLC. Fun. Okay. Ooh. What does this do? Assembler. Okay. So we just feed it dev null. Oh. Oh, okay. That's a lot of output. Ah. Okay. So these are the available CPUs, it looks like. And then features. Joy. Jeez, that's a lot. Okay, cool. So we use generic CPU, I guess? And then no additional features or target options. So that creates the target machine. And then, okay, that comes from, okay. That comes from the triple, it looks like, okay. So now we can configure a module to specify the target and data layout. It's recommended, sure. Yeah, I'm not reading that, I can't lie. I don't have the mental capacity for that. So we set the data layout for our module, and then we set the target triple. So we make a code gen pass, and we set where we write the output to. Okay, nice. Let's see. What to do here? What to do here? Alright. So I want to keep the JIT support for now. So I don't want to change that at least. So we're going to keep run interactive the same. But what we will change is run file input. So we can comment out right to bitcode for now. And then we're gonna, I guess we can do this. And here, let's figure out the printing. So, what do we want to call this? Let's make that a thing. And then in this LVM giant globals file, let's make that a thing there. We want this down here, it looks like. I don't like this name, that looks ugly. Right to object. Right to object? Right object. Yeah, let's do that. And then let's copy that. Let's make this one bitcode out file name, and then let's make this one. Let's make this one object out file name. And then this one should be .o, I guess. Okay. Yeah, that seems sane enough at a glance. Yeah, there we go. And then we pass in. First, let me fix this. Let me make this a C string. And now let's make the actual thing. Okay. So first we need to get the target triple. That seems simple enough. Sys. Okay. Ugh. Oh, this is an LVM thing, I see. Where does this come from? What? Yeesh. And then what's the include here? What do I need to include? That doesn't help me. Is there a header here anywhere? Any any semblance of telling me where I am right now? Help? What is this? Okay, sure. I have no idea where this is supposed to be, but we'll find out soon enough. I fixed a typo in one of the docs. That's huge. That now you can technically put LVM contributor on your resume. That's what's up. Do it 5 more times, and I think Latin will just straight up give you contributor access, if I remember correctly. It's like crazy to think about, by the way. Just make like a handful of commits, and you just get like straight contributor access to the main LVM repo. So which of these am I supposed to import? Is it this one? Oh, that's not it. Is it that one? It's not that one. Okay. We're just gonna do something really ugly here. And just hope for the best here. Okay, I regret doing that. We're not gonna do it that way. we're not gonna raw dog that. Let's take these ones. Okay. So then we already have this one. We already have this one. We don't need that yet. We don't need that yet. We don't need that yet. If I delete that, what happens? Nothing happens. I delete that, and it gets mad at me. Okay. So what happens if I do it this way? It doesn't get mad at me. Okay. Well, this one seems the most sensible to have right now, so let's just do that. 5 typo fixes into force push speedrun. That would go hard, Loki. Oh wait, it wasn't that one. It was this one. Ugh. Okay. Okay, seems like it's not mad at me anymore. So we have the target triple. So now we need to call this mess. I'm not gonna type that, so I'm just gonna paste that in. Yeah. So let's select all these, normal, word, insert, LVM. I hit escape, I'm stupid. There we go. Stud string error. Sure. Oh, what was that wall? Ooh, okay. Just empty string is huge. So we need LVM target registry. And we look up the target triple. Oh, and then error is where it's printed. Okay, if there's an error. That's incredible. This is little t. So let's. Okay, so then that finds the target. If target is a null pointer, then we print to errors. I need to wrap this with this. There's a way to just like error by calling a null pointer, right? CPP how to crash program. Okay, let's just do that. Does it let me do that? It does not. Abort. Yeah, okay. Dereferencing null pointer is pretty funny to me. Okay, so yeah, we're doing it this way because it's a helper function. Okay, so now we do this thing. There's an LVM report fatal error macro. Does this exist? Aha! Well, huh. Is there anything else here? I guess it is. It just lives in this oxygen. It's probably in an implementation. Yeah, that makes sense. It's probably in here, surely. Oh, this didn't include, that's why. Okay, let's go to let's go to the GitHub. Surely it's in here. Wait. Where's the... Oh, that's the button. Ah. Let's see. This is definitely not the intended way to do this, but let's just do it anyway. Could be this? Should be this. But does that exist in a header? That one might be a little bit more dicey. There we go. Oh, deprecated. Oh, but deprecated for the other ones. There we go. Okay, so let's just... Oh, I can just do that? Let's just do that. And then... What does this take again? Error. Yeah, I'm too lazy to figure this out right now. Let's just abort. We'll just abort and call it a day. Seemed a little bit hacky. Okay, so we need to make the target machine real quick. So we'll just... So it's generic. Features equals empty. So this is target. Yeah, target we made. Create target machine. This takes in... Oh, that's a lot of stuff. Okay. So target triple, CPU, features, takes in options, and then reloc. Oh, I see. Okay, that makes sense. There we go. And then what else do we need to do? We need to set data layout, or we need to configure the module. So module set data layout. Yeah, this just looks like a bunch of pretty much just boilerplate functionally. And then set the target triple. And now we just vomit out code. So, yippee. We already have a file name that we pass into this, so let's do it. Error code. We can steal this a little bit here. That didn't save me any keystrokes. Oh, it just occurred to me I should add error handling for the other stuff, but I'll do that next time probably as a thing before adding a debug output. LVM errors, error. What am I missing? Oh, I'm blind. That. Am I chop shit? No. I can't read. I might be cooked. Finally we vomit out the code, then we define a pass that vomits out code, then we run that. So oh, it uses the legacy pass manager. I forgot about that. This doesn't exist. Equals. Oh, right. This is a name. This is not a type. This is an object file. And then file pass dest. Where did dest come from? Oh, the outstream. I see. It's OS here. Null putter. And file type. I'll probably look over this again tomorrow, just so I really know what's happening. And then abort. What am I messing up here? There we go. Alright, so we make the pass. And then pass.run on module, and then os.flush. Flush. This takes a pointer. Okay. Let's see. How do we do this? Ooh. This takes all. Okay. I don't think that's changed anything, to be honest, compared to what I had. So let's make this. Let's make this. let's take a quick little program from here. What's a good one? Yeah, fib's always safe. Let's do this. Yeah, let's get rid of this even. We'll just do good old recursive fib, because I hate performant code. I hate performant code so much that I've decided to go into compilers to make performant code, so I can hate on it more. Let's just make a... Let's do that. Include IO stream. So in this extern, we do double fib of double. What? Oh, that's a C++ file. Whoops. There we go. Fib of... Let's do 5. Everyone likes the 5th one, I hope. Okay. Alright, so that works. So let's take this, let's pass in tests fib. We have an object file now. So then, do I have a, okay, I don't have a test directory, unlucky. So let's just claim, let's take tests.cpp, and then let's add in kaleidoscope. Yeah. And then let's run. And there we go. Okay, we got it working. Wait. 1, 1, 2, 3, 5. Yeah, it is the 5th one. Okay. Had to double check real quick. So yeah, we output object code now, and with that we've gone from source to assembly with LLVM. Yeah, I think that's going to be it for today. Let me just clean this up. Let's get rid of that. That. So we get the Fibonacci test, and then we take that, we update that for obj output. And then we have implement emitting to objects code. Yep. So yeah, that was a lot today. We finished letting users use variables properly, and we got code gen working. Yippee. So yeah, that's gonna be it for today's stream. Thank you all for being here. It really means a lot to me. When I first started streaming, even just like, how long ago has it been? What day is it? It's day 18. Yeah, even just like 2.5 weeks ago, I didn't expect to get more than like 10 viewers at any point. So it really does mean the world that y'all are here. Make sure you like the VOD and subscribe to my channel. And once this becomes a YouTube upload proper, leave a comment. It helps out with the algorithm. My LinkedIn and my GitHub are in the description. Make sure you add me on GitHub and connect with me on LinkedIn. And yeah, see y'all tomorrow. Take care, y'all.